Okay, very first chapter, very first section, I should say, of the very first chapter is the coordinate plane. As I mentioned earlier, most of the stuff that we're going to do in chapter 1 is definitions, and we'll do a little bit of algebra review as we work through those definitions. So we're going to be writing a language here, and that language has to be consistent for everybody. So you'll see some definitions today. When we talk about those terms, we need to make sure that everybody's on the same page. Okay, so you're going to be writing definitions that everybody's comfortable with. We're going to start with this guy, Réne Descartes. Famous French philosopher, mathematician, did a whole bunch of cool stuff. He is responsible for the Cartesian coordinate plane. That's the first thing he did. And like many mathematicians, they have a tendency to name things after themselves. I'm going to go out on a limb here. Does anybody know what else he's famous for? I would be shocked if anyone knew this. Going once, going twice. He's also famous for the quote, I think, therefore I am. How many people have heard that quote? Raise your hand. Awesome. The culture in the root. Cogito ergo sum. Okay, so let's stop for a second. I know you're still writing, but we can talk. What on this slide did you write down? What do you think on that slide you might need to know? Did anybody draw his picture? Good, you probably don't care what he looks like. Did anybody write down the two things that he's famous for? Good. Did you write down every word of that slide?
No.
Good. There'll be a lot of stuff on slides that are there, not really for you to write them down, just to complete and give us a nice complete package of a slideshow there. Okay. We're going to focus on number 1, obviously. We don't really care about his famous quote, even though it's pretty good. I think, therefore I am. In other words, if you can think, you must exist. What we want to talk about is that guy, the coordinate plane. Specifically the Cartesian coordinate plane, you would probably call it a graph. Am I right? Okay, so let's start with this guy. What's that thing called? Tell me your name. Ashley, what do you got?
X-axis.
X-axis. Okay, bonus points, Ashley. I will give you an A for the semester. You don't have to do anything for the next 90 days? Yeah. If you can tell me the fancy name for the x-axis. Okay. Well, I gave you a shot. It's called the abscissa. So you're sitting around the dinner table tonight. If you want to impress the family, fire that one off. Hey, by the way, do you guys know the x-axis is actually called the abscissa? Which sounds like something you need to see the doctor for. Wow, you guys are a rough class. Jokes don't get much better than this, so bear with me. Okay, visual. What's that thing? Tell me your name.
Paul.
Paul.
It's the y-axis.
Okay, same offer I made. Ashley. You can tell me what the fancy name of the y-axis is. A for the semester. You're done. You can check out. Spend all second or third. This is third period.
Yeah.
Third period eating honey buns and Mountain Dew for the rest of the semester.
Oh, abscisso.
Not a bad. This would be the female, and this is the male. This is the abscisso, and this is the abscissa. Not a bad guess. It's better than, I don't know. It's actually called the ordinate. You gonna tell me you knew that? Okay, good. Oh, I knew that. What's that thing right there? Tell me your name.
Krishna.
Krishna, what do you got for me?
The origin.
The origin, excellent. So the point where the abscissa and the ordinate, or realistically the x-axis and the y-axis intersect, would be called the origin. What's that guy? Did you see that, by the way? It's not there, it's there. What's that thing?
Quadrant 2.
Name?
Madeline.
Madeline. No, just that thing right there.
Dot. Oh, never mind.
It is a dot. Correct. More mathematically speaking, what would you call that thing?
A point.
Excellent. It's a point. How many points are on that coordinate plane, Madeline?
2.
Only two? The origin and the point we're talking about, right?
Yeah.
Okay, how many points are on that coordinate plane that we can't see or that aren't labeled?
Infinite.
Yeah, there's a lot of them there. I'm not gonna label them all. We call that point xy. What's the fancy name for a point on the coordinate plane?
Coordinate pair.
Tell me your name.
Nicole.
Nicole? Close. You got the second word right. A pair, because there's two things. Have it?
An ordered pair?
An ordered pair. Well done. It's an ordered pair because it's in order, and there's two of them. It's not rocket science there. You guys know all this stuff, right? Okay, good. That is quadrant 1. So anything above the x-axis and to the left, sorry, that's the right of the y-axis would be quadrant 1. If this is quadrant 1, then this would be quadrant
2.
Oh, gotcha.
4.
Sucker, that's 4. 2's over there. What's true about all the points in the first quadrant? Nicole?
They're all positive.
They're all positive. The x is positive and the y is positive. Nicole, let's stay with you. If we go to quadrant 2, what's true about all the points in quadrant 2?
All of the x points are negative and all of the y's are positive.
Well done. You're doing such an outstanding job. Let's continue into quadrant 3.
They're all negative.
Everything's negative, and then quadrant 4.
X is positive, y is negative.
Well done. Good. Okay. Other than these two fancy words, this should all be review, right? Coordinate plane, if you want to get fancy, it's the Cartesian coordinate plane because it was created by Réne Descartes. And that'll be that. Okay, so that's pretty much algebra stuff. And we're going to take some of those algebra ideas and drag them into the geometry world. Can I move on? We're all good with this? Awesome. Okay, first question for argument. What is a point? Madeline, is that right?
What? Yeah.
You told me that thing was a point before, right?
Yeah.
Okay, what's a point?
Where an x and a y, or two ordered pairs, are placed.
Good. On that previous slide, that would be a good definition, but now we're switching into geometry mode. So does anybody have any idea what a point is? Now you'll notice it says undefined terms up there. There are 3 building blocks in geometry that we're going to talk about that we're actually not going to define. Well, how can we define something that we're going to use as a building block? The analogy I have for you is try to define the word time. What is time? Well, that's not an easy definition, but what we can talk about is all the effects of time. Well, time makes the clock go around. Time makes me get older. Time does this, does that. We don't actually have a definition for it. The same is true about a point. We're not really going to define the point. We're going to describe it. Okay, so I'll get you started on this one. It's a location. Now this is the thing that freaks people out. It has no shape nor size. They are infinitely small. So if they have no size, how many can I put in a Dixie cup?
An infinite amount.
An infinite amount. Okay, this is kind of an important idea. Is everybody with Nicole on that? I can put an infinite number of points in a Dixie cup. All right, Nicole, so I take that Dixie cup full of points and I put it in a garage. And now I fill the garage with points. How many points are in the garage?
An infinite amount.
Which one is bigger, the Dixie cup or the garage?
Well, neither. They're equal. Because if you can put an infinite amount in a Dixie cup, you can also do the same thing in a garage. The size of the container doesn't matter.
Everybody okay with that? Don't shake your head. You shouldn't be. That makes no sense. How can the things that I put in this little cup match the things that I put in a huge garage? It doesn't make any sense, but she is right. Because we're dealing with infinity, the human mind doesn't deal with infinity very well. So we just kind of go with it. She's right. Infinity is infinity. There's no such thing as infinity plus 1. It doesn't work out. Okay, so we got these things that are really, really tiny. In fact, they're so tiny they have no size or shape. That's our first building block. Think about making Legos or playing with Legos. You guys know what Legos are, right? Okay, good. When you're working with Legos, you take little Legos and you put them together and they build bigger things. As far as how to denote a point, we're going to use a capital letter. There is no symbol for a point. So when we're talking and using this geometry vocabulary, if I'm talking about a point X, I just write capital X. And so if you see a capital letter, you will learn that that just means the point. And so we have a problem here. I want to be able to draw points. I want to be able to put a bunch of points together and build other objects, but if it has no size, how can I draw it? And the answer is you can't, so we cheat. We come up with things to represent a point. Just like if I go up to the board and I draw a picture of a dog, that's not really a dog, it's a drawing of a dog. Same thing is true here. We're going to use a clicker that works. There we go. We're going to use a dot to represent a point. Just like in the previous slide with the Cartesian plane, we had a big honking red dot on there. The same thing is true for a point. Your pencil is not sharp enough to draw a point, so we just make it a dot. And it looks something like that. That's the point X. Okay, let's take a breather here. How are we doing so far? Good? Not going too fast? Good? Getting everything written down? Understanding the concepts? Okay, because again, this is where we're starting, and this is really, really important, because as I've mentioned a number of times, this is the building block for everything else we're going to do. And remember, there's no symbol for X. You just write capital letter X, capital letter A, whatever point you're talking about. Okay, second term. And again, these are building blocks. So we start with the smallest thing, which is a point. And I put a bunch of points together. And if I put a bunch of points together, I get something called a line. So the question, as it says up there, is, what is a line? Who wants to take a stab at it? Nobody, because you're all chicken. Nothing? Okay, for discussion purposes, let's think of our points as golf balls. So I've got a huge bucket of golf balls. How would I turn those golf balls into something we would consider a line? What would I do with them?
If you line them up, like.
If you line them up, see? Get it? Line them up?
Yeah.
Yeah, did you mean that to be?
No.
Oh, it's pretty good though. I'm totally stealing that for 8th hour today. Thank you. If you line them up, how so?
Like that.
That's not a horrible description. That'll work out really well on the video, by the way, because you can't see anything, just the screen. You do that with them. What about this? That's not a line. So then how would you describe the difference between this and this?
Straight.
Straight. Does that work for all of you? I mean, I think it's safe to assume we all know the difference between a curve and a line. Is that safe?
Yeah.
Okay, good. Notice my definition, or not definition, the description there, because it's undefined, is really loosey-goosey. But it does come back to this idea of being infinitely small. So that line that we have, that's straight, that's made up of a bunch of points, has no thickness. If you take any 2 points, there's got to be a line that goes through it. You might not see the line, but there will be a line that goes through them. You can draw that line. Just like when we went back to the coordinate plane, I asked Madeline, right? I asked Madeline how many points were on the screen, and the answer was infinite. We just didn't label them all. They're there, you just don't label it. And then naming it, let me bring the picture up here first. Okay, there's a line. 2 ways to name a line. The first way is to pick any 2 points on the line. In this case, I'll pick B and C. because they're the only 2 points that I have labeled on the line. List the 2 points and put a little line over it. Is that the same thing as this? Yeah. What does it mean? It means take the point B and C, draw a line through it. That's the line I'm talking about. We didn't answer this question, though. Why are there arrowheads on it? Yeah.
Shows that it's going on.
It goes on forever, correct. This is not a line. This is a representation of a line. The other way that we can name a line is use a lowercase italicized letter. So that would be the line M. Most of the time, however, we're going to use that method. But you will see both, and you need to be able to work with both. Anybody want to guess what the third term is? Took a point, has no size. We took that point and we lined a whole bunch of them up and got a line. So we went from, how many dimensions for a point, by the way?
1.
Nope.
0.
0. And we took that point and we stretched it in 1 dimension, so a line has 1 dimension. And now we take the line and we stretch it the other way, and what do we end up with? A plane. And it could be a shape, yes. We could be talking about a rectangle, a triangle, but a plane is a little bit different. The easiest way to think about a plane is an infinitely large piece of paper. It goes on and on forever and ever and ever. Obviously it's flat, extends in all directions. Now we can't draw that, so the way we represent that is by drawing a little rectangle or parallelogram looking thing, which is there. Okay, so that's the plane. 2 ways to name a plane. I just did that. 2 ways to name a plane. One is by the fancy script letter down in the corner, so that's the plane K. Or pick any 3 points on the plane, A, B, and C, and name it by the 3 points. Only 3 points. There's no symbol for plane. You just write out the word plane and then A, B, C, or plane K. So that's 2 dimensions. Now suppose I take that plane and I stretch it the other way. What do we end up with? What's the 3-dimensional equivalent? No. In that case, we get space. That's the 3-dimensional world that you live in, which surprisingly enough, people have the hardest time with. Okay, so those are our 3 main building blocks: points, lines, and planes. They're also undefined because we don't have a succinct definition. Virtually everything from this point on will have a definition. And 90% of the time, you're going to write those definitions. I'll help you, I'll describe it for you, but you're going to actually write the definition, which frustrates some people because you just want to be told what it is. Okay, how are we doing so far? Good. Any problems? Questions, concerns? Hot diggity. Let's move on. First 2 definitions, because again, those were undefined terms. What does the word collinear mean? I'm not giving you this one. What does col mean? Together. What does linear mean? Line. So what does collinear mean? Who's talking? Okay, good. I must be hearing things then. And that happens when you get old, you start to hear voices. It's very scary, especially late at night when you're alone. Come on. What's collinear? You can make me call on people.
Lines together.
Lines together. It's not horrible. It's not perfect, but it's not horrible. It's a yeah, I mean that's infinitely more than anybody else said, so I'll give you props on that one. Emmett, what do you got for me?
I have lines that are together.
Lines that are together. No. Points are collinear, I'll give you a hint. You want to take another stab at it?
Points that are on the same line.
Beautiful.
Same line.
2 or more points on the same line. Co-together, linear line. Together on the same line. Now, let's see how you do with the next one. What does non-collinear mean? Go ahead.
2 points that are not on the same line.
Hot diggity. Points not on the same line. So we got some prefixes working here. Co is a prefix, non is a prefix. All right, let's see how you do with pattern recognition now. We talked about that already. What does coplanar mean? Michael?
Yeah.
Go ahead.
2 points that are on the same plane.
Love it. 2 or more points that lie on the same plane, or in the same plane. You can use those terms interchangeably. All right, Michael, we stay with you since you did such an outstanding job. Do you think you could tell me what non-coplanar means?
2 or more points that are not on the same plane.
Perfect. So when you're done writing, if you look around the room, somebody describe a plane in the room. Oh, we've heard enough from you today, Nicole. Thank you, though. Who haven't we heard from? Is it Will? Is that right? Will, where's our plane in the room? Or I should say part of a plane in the room. Obviously, I don't have an infinitely large plane in the room, but where in the room do you see a plane?
The windows.
Windows, good. Okay. So, what points would you say are on the windows or in the windows? Are there any? Doesn't look like there's anything stuck to the windows, right? All right, give me another plane somewhere else around the room. Let's give it a shot.
The board.
The board, good. So there's a bunch of points stuck on the board there. There's the words that you see on the smartboard. There's the gabillion magnets stuck all over. If the front board or the front wall is the plane, Will, give me a point that's not on that plane.
Like snow globes that are on the top.
Beautiful. The buckyballs on the ceiling, the posters on the back wall, the vent on the ceiling, the flag on the ceiling. From what country? Cricket. No one knows that flag?
No.
Okay, we'll come back to it. Lots of different examples. Okay. We good on these? Awesome. Okay, in your notes, sketch the following situation. And make sure, what we're doing here is not only making sure you understand the things we're using, but also that you know how to label them correctly. So in your notes, sketch a line XY passing through the plane R, and label the point where it passes through the plane by the second letter of your first name. Second letter of your first name. So if your first name is Susie, you would use U. Okay. If you need help with that, if you don't remember your first name, you're out of luck because I don't know any of your first names yet. Some of yours. No. And just so you know, this is not on a coordinate plane. This is not a coordinate plane, this is just a sketch of what we've talked about in the last couple of terms. So, in other words, can you draw a plane? Can you draw a line? Can you draw the line intersecting the plane? And when you see the answers to these, there's a lot of little minutia that you're gonna, do you understand the word minutia? Minutia is like little things. There's gonna be a lot of little things that you miss. You'll also see how fancy you can get. Ooh, look at you. Alright. Alright, do your homework with Dad, he knows what he's doing. Or he hires out for sketches, right? What do you charge him to sketch? $50?
200.
Oh, way to ramp it up. Number 2. 2 lines M and M that intersect at the point Q. Take one, pass it back. Take one, pass it back. Second one a little bit easier? Yeah. Okay, good. Take one, pass it back. These are called graph patches. We won't use these a ton because most of your work is going to be digital, but if you're doing work on paper and or you have to do some graphing on paper, the graph patch makes your life a lot easier because you have a coordinate plane. So stick that sticker in your notebook or in your notes because you're going to use it for number 3 when I pop that up. Number 3, plot some points, and in particular plot those 3 points, C, A, and T, and then connect the 3 points using a straight edge. I don't have a straight edge. Yes, you do. You can use your ID, you can use your calculator cover, you could use your friend's ID, you could use the battery cover from your calculator, you could use all kinds of different things. Your credit cards. I'm sure you all have your credit cards with you, right?
Yep.
Awesome. You brought your credit card? Why not? How did you pay for your card? When you plot the points on the coordinate plane, make sure some of your graph patches will already have the coordinate, the abscissa and the ordinate on it, or the x and y axis. If it doesn't, draw it in. When you plot the points, make sure you label the points with the letters. You don't need the coordinates because we can get that off the graph, but you should label it with the letters so we know which point is which. Graph right here, right? 20, 20, 15, 10, 5, hour, 55, 50, 50. Go home. That's how it works. You just have to figure out what hour it is. Boom. Obviously, it's going to be 15. Okay, got all 3? Let's see how you did. A lot of people struggled on number 1, and that's just from lack of practice. Since a plane is a big flat surface, you want to try to make it look kind of 3D because you can't consider the paper that you're writing on to be the plane because then how do you draw a line going through it? So it should look something like that. So let's talk about that. The yellow part is my plane. So we're getting kind of a 3D look here. Here's the line, and then there's the point. By the way, fancy, if you want to impress your friends, the point where a line intersects a plane is called the foot. Why is that dashed? Michelle, is that right? Why is that dashed?
Because the points in the way of x and y coming together.
Not horrible. Good. Everybody understand that? We can't see this portion of the line, it's behind the plane, so you dash it so that you know it's there. And then when it comes back out, obviously it's solid there because that would be something you could see. So we're pretending to be able to have X-ray vision to see that line. Questions on any part of that? Good. Use the fancy script letter to denote the plane, and then labeled the points. One thing that you need to understand is that even though you can only see 3 points on the line, there is actually an infinite number of points. We just picked 3 special ones and gave them names, and those names are capital letters. Any problems with one? Well, a lot of you had problems with one, but now do you understand what you're supposed to do? Any problems with 2? That was pretty straightforward. Just make sure things are labeled correctly. And then number 3, have something like that. Okay? We solid? Any problems?